Assalamualaikum warahmatullahi wabarakatuh. Let me introduce my name. My name is Triawansyah Persada. I'm a presenter for this paper. And then four of my friends is Mr. Ahmad Zamheri, Mr. Diki Saprianto, Mr. Carlos, and Miss Indri Arianti. And today we would like to present you our research, the effect of parameter process 3D printer technology digital like processing to geometric object. Before it, for the first time, for the background, we would like to showing you about the industrial revolution from 1.0, 2.0, 3.0, and 4.0. And then, what is the industry 4.0? Industry 4.0 is the who's make human easy to connect with other human, with industrial machine, and with the environment around them because the internet, all of connected by internet things. And today, this is our DLP or digital light processing or our printing. And we would like to know you why we choose this research about the shaft, because in the shaft we know the function of shaft is very crucial. Indeed, the shaft need alignment, cylindricity for make perfect using in the machines. How we know that? We know our part or our component is very useful or very perfect if the component assembly with other component. And then this rapid prototyping, digital light processing. What is that? It is a kind of 3D printer whose use compaction of photopolymer on the machine uses in ultraviolet laser. The ultraviolet light shoots out following the pattern who made in 3D software. The raw material for make this object we using resins, and then this we call it SLA technology. Then how does it work? Look on these ones. This we call it build platform, and this is the source of light. And then when the light shoots out the resins, automatically the build platform going up and down following the parameters. Okay, the crucial part in this printer is this one, pad assembly for tank the resins, and then this build platform and this source like source, and we control this with a microcontroller, control this printer. Okay, this is the table of parameters. This is a pixel factor, and then this parameter which we can control it. These have layer thickness and exposure time. And this one is the designs of component who we do research or our specimen for testing. Have a diameter 20 millimeter and length 100 millimeter. Next. Okay, how to make SLA DLV 3D printing object specimens. Before we would like to design the solid model and then convert the solid model to STL program, and then we give the resins to the pad, and then we put before we put the slice setting. After that we move the 3D printer, and then the result is this soft look in the bottom. And then after that we do a testing a specimen, a cylindricity measurements like this one. This ANOVA results from the cylindricity measurements. Yeah, this is the result from 27 specimens. This is the have a 9 combination, and every combination have 3 replication, 3 times replication. Okay, these ANOVA results from the cylindricity measurements is have a mean standard deviation and the ratio of specimen test results. Okay, this is our final calculation or results. Layer thickness, and then pure error, and then extraTC. This is a look. The model is significant. We use ANOVA for find the results and the conclusion for statistic data. And then these the results from cylindricity test specimens. The layer thickness have effect of 41%, and then exposure time have a 1%, and then the last one is interaction factors, layer thickness, and exposure time have a 52%. The effect that. And then the conclusion. The results analysis known that the factors of effect to the cylindricity of shaft is layer thickness 41%, exposure time 1%, interaction of layer thickness and exposure time 52%, and then from the analysis of the cylindricity measurements of shafts, the most optimal combination of parameter is layer thickness 0.075 millimeter and exposure time 15 seconds with a value 0.02 millimeter on the cylindricity deviation. Okay, this is all of our presents. If you have any question, just call me or call Mr. Diki Sefrianto as a corresponding without hesitate. Thank you.